Hershey, Lay's, and Cheetos. Iconic names among the millions of consumer products you've likely heard of at least once. But behind those familiar brands lies more than just addictive flavors. It's a fierce race of technology and speed within a multi-trillion-dollar food industry. So how do these giants manage to produce such massive quantities with near-perfect precision while continuously shaping global consumer trends? In this video, we peel back the sweet, glossy surface of these brands to uncover the little-known operational secrets driving one of the largest and most sophisticated industries in the world. Every year, millions of gingerbread house kits are produced on industrial assembly lines, becoming iconic holiday treats with their golden crispy cookie walls, colorful candies, and the warm ginger aroma of Christmas. The process begins in giant mixing tanks where flour, brown sugar, molasses, butter, and ground ginger are precisely measured and blended before moving to the kneading machine, forming a uniform dough block weighing nearly 200 kilograms per batch. This dough then passes through a high-pressure steel roller system, pressed thin to just 6 to 8 millimeters to ensure a perfectly flat surface for cutting. While the dough is still soft, patterned rollers stamp doors, roofs, and decorative details directly onto the sheet. Once baked to a crisp texture, the panels become as sturdy as miniature bricks, ready for assembly. The wall and roof pieces are bonded together with royal icing, a mixture of egg whites and powdered sugar that bakers often call the Christmas epoxy glue for its incredible sticking power. Finally, candies, sprinkles, and icing details are added to complete a lively gingerbread house that looks just like a tiny winter scene. And as soon as the gingerbread house production comes to an end, the assembly line immediately shifts its rhythm to another Christmas icon, the candy cane. The journey of crafting this legendary treat begins with a step that seems simple, but actually determines the entire quality: mixing and cooking the sugar. Sugar, glucose, and syrup are poured into large kettles, heated, and continuously stirred until the mixture becomes thick, uniform, and crystal clear like hot honey. Once it reaches the ideal consistency, the syrup is poured onto cooling tables or steel conveyor belts, where technicians or machinery stretch and fold it repeatedly to develop the perfect elasticity and airy texture. At this stage, the candy mass is divided into two portions, one left in its natural white color, and the other mixed with just 0.3–0.5% coloring to achieve its signature red hue. The two masses are placed side by side and fed into a high-temperature rolling and pulling system. Under continuous pressure, the red and white layers are compressed together without blending, forming perfectly straight stripes. As the combined candy block moves through the twisting machine, the rotating shaft gently spirals the strip into a long cylinder, gradually thinning it down to the width of a pencil. This is when the iconic red and white swirl becomes the most vivid. Finally, the candy rope enters a high-speed cutter, sliced into segments about 12 to 15 centimeters long. While still soft, each piece is bent by the conveyor system to form the distinctive hook shape of a candy cane before being fully cooled to lock the form in place. Say goodbye to the soft, twisted candy ropes. We're stepping into the crispy world of Lay's, where every potato is carefully selected and processed before becoming part of the more than 200 million chips produced each day. Every potato used for Lay's goes through a streamlined yet almost perfectly precise process. After being washed and sorted, the potatoes enter a specialized peeling machine. Inside the rotating drum, the surface of each potato rubs continuously against the chamber walls, causing the skin to come off within seconds, while strong water jets wash away any remaining impurities, leaving behind smooth, flawless potatoes ready for slicing. Immediately afterward, the potatoes are transferred to a high-speed slicer. A set of spinning disc blades applies gentle pressure to each potato, producing slices just 1.5 millimeters thick, a measurement Lay's has standardized after years of optimization to ensure every chip fries quickly, cooks evenly, and achieves its signature crispness. From the high-speed blades, the process shifts into a stage of precise heat control. The potato slices enter a vat of refined oil, kept at a stable 175 degrees Celsius, and are fried for about 3 minutes to develop a uniform golden crunch. The oil is continuously filtered, allowing the system to operate 24/7 and process tons of potatoes per day while maintaining consistency. Thanks to this closed-loop system, Lay's preserves its iconic, thin, light, crispy quality on a global scale. If Lay's is a race against time, Hershey is an art of structural control. Every year, the Hershey Company produces more than 500,000 tons of chocolate, fueling a worldwide wave of sweetness. The journey of a Hershey's Kiss begins immediately after the tempering stage, when the chocolate reaches its perfect smoothness and glossy finish. The liquid mixture is fed into a molding machine, dropping onto the conveyor in the signature little kiss motion, the very origin of the name Kisses. From there, the chocolates enter an almost endless cooling tunnel, where the stable temperature allows each piece to solidify evenly. Those that meet the quality standard are wrapped in foil, fitted with the iconic paper plume, and sent along a spiral conveyor toward the automatic weighing section. Alongside the Kisses line, the Hershey bar production system runs continuously with preheated molds ready to receive streams of liquid chocolate with absolute precision. The molds then move into a tightly controlled cooling chamber that ensures each bar sets quickly while remaining silky smooth. Once fully cooled, the machine flexes the molds gently to release the bars, then flips them over to drop the finished pieces onto the packaging conveyor. Every year, billions of ice creams are produced in modern factories, meeting the cooling cravings of millions worldwide, becoming one of the most iconic products in the frozen dessert industry. The journey of a batch begins in giant mixing tanks, where fresh milk, heavy cream, sugar, and flavorings are blended in precise proportions. The mixture is homogenized to break down fat particles, creating a silky smooth texture, then pasteurized at 80 to 85 degrees Celsius and rapidly cooled. Finally, the ice cream is aged for several hours to allow the ingredients to meld, stabilize the texture, and enhance creaminess, preparing it for the next stages on the production line. Once ready, the mixture is pumped into the flash freezing machine, the heart of every ice cream factory, where air is whipped in at precise ratios to create fluffiness, while ultra-fast freezing produces the signature smooth structure. This is also the stage when chocolate, syrups, almonds, or cookie crumbs are added at the end to avoid being crushed. From here, the ice cream is shaped into bars, cones, or tubs, then passed through deep freeze tunnels at 40 degrees Celsius to lock in the structure, ensuring that by the time it reaches consumers, every spoonful is creamy, rich, and full of original flavor. It's this meticulous process that allows famous brands like Häagen-Dazs, Ben & Jerry's, and Baskin-Robbins to deliver a perfectly consistent taste experience, cementing their status as icons in the global ice cream industry. They may look like nothing more than puffed corn pieces, but they've built a snack empire worth more than $20 billion. This is the legendary story of Cheetos, the orange cheese king that has captivated the world for nearly a century. The journey of Cheetos begins in industrial corn dryers, where kernels are dehydrated to the ideal moisture level before being milled into fine cornmeal with precisely controlled particle size. Immediately after, the meal is transferred into CableV's automated dosing system, where moisture is adjusted to 15 to 20% and mixed with the brand's proprietary formula to reach the perfect condition for the next stage. The conditioned dough is then fed into the Wenger X85 extruder, where temperatures reach 280 degrees Fahrenheit and high-speed rotating screws generate intense friction, transforming the mix into a pliable, molten-like mass. Under pressures of up to 300 psi, the dough is forced through a die and instantly puffs upon contact with air. The critical moment that creates Cheetos' signature airy, crunchy texture. Once expanded and crisp, the pieces move into a 25-foot flavoring drum, where hot rice oil and real cheddar cheese powder are sprayed through a high-pressure rotating nozzle system, coating every single snack evenly. Every year, Americans consume nearly 40,000 tons of marshmallows, and during the summer camping season alone, they go through up to 50 million bags to make s'mores by the fire. The marshmallow making process begins in a gelatin hydration tank, then moves into a high-capacity whipping machine, where hot syrup is streamed in while air is incorporated at high speed. Few people realize that marshmallows are 90% air, and it's this ultra-fine microfoam that gives them their signature soft, bouncy texture. Once the mixture reaches the ideal stability, it's no longer poured as a solid block. Instead, it is extruded into long, warm ropes that are still alive. The internal microbubbles continue to expand and settle, giving the ropes elasticity as they puff slightly and self-stabilize right on the conveyor. These marshmallow ropes are extruded onto a bed of fine starch, an edible industrial sand that prevents sticking and keeps the surface dry. After the ropes fully set, they travel to an automatic cutting system where fast-cycling blades slice them into uniform segments. The cutting speed must match the conveyor's movement with absolute precision to ensure each marshmallow is identical in size before it enters the packaging line. In the trillion-dollar food industry, yogurt remains one of the fastest-growing categories, becoming a familiar source of probiotics for millions of families every day. The yogurt-making process begins with quality inspection of the milk, followed by fat separation using a 6,000 RPM centrifuge and pasteurization at 85 to 90 degrees Celsius. After homogenization and cooling, live cultures are added to initiate fermentation, creating the signature mild tang and smooth, creamy texture. From here, fruit yogurt enters its most complex flavor phase. The fruit puree is prepared in a sterile zone using a vacuum cooker, where fresh fruit is crushed, heated, and concentrated together with juice and starch to preserve color and aroma without burning or oxidizing. Temperature and viscosity are continuously monitored to ensure every batch of strawberry, mango, or blueberry meets strict consistency standards. Once fermentation is complete, the line moves to the layering stage. A dual-pump Tetra Pak system precisely dispenses 15 to 25 grams of fruit puree into the bottom of each cup, then fills the yogurt layer on top in less than a second, creating a stable, visually appealing layered structure. Finally, the cups are automatically sealed, labeled, inspected by AI cameras for defects, and checked by electronic scales before entering the final packaging stage. Thanks to this fully closed process, every cup of fruit yogurt reaching consumers maintains its creamy smoothness and the distinct freshness of real fruit in every spoonful. Pizza, a small circle, yet a powerful symbol of the entire fast food industry. It's often called an addiction flavored with oregano and tomato sauce, capturing the hearts and stomachs of billions across the globe every single day. You can find a $5 pizza baked in a brick oven on a Naples street corner, or order a $12,000 version at a luxury restaurant in New York, topped with caviar, truffles, and gold leaf. And while a pizza can be sliced into 8 even pieces, the battle for each slice of the market is far from evenly split. For decades, Pizza Hut reigned supreme with its classic dine-in restaurants, family-friendly ambiance, and broad menu. But since 2018, Domino's flipped the script, becoming the largest pizza chain in the US by revenue, thanks to its massive automation systems and highly optimized logistics network. The race is so fierce that even McDonald's, the global fast food titan, once tried to enter the pizza market back in the 1980s. But eventually, even McDonald's had to retreat quietly, unable to keep up with Domino's. So yes, pizza is more than just food. It's a global culinary icon where creativity, technology, and business collide on a single crispy crust. Which pizza is your true love? Drop a comment below and share it with me. And right now, join me on a breathtaking journey through endless wheat fields, the very beginning of those golden, crispy crusts that make the world fall in love with pizza. In June, across the states of Kansas, the wheat capitals of the United States, endless fields turn a brilliant shade of gold under the summer sun. It's a familiar signal. Harvest season has begun. Right then, the massive combine harvesters begin to roll. Each one stands nearly 3 meters tall, stretches over 10 meters long, so massive that anyone standing beside it looks completely dwarfed by the steel giant. Small in size perhaps, but still in full command of the entire harvest. At the front, a sharp cutting blade glides just above the ground, neatly drawing whole stalks into the machine. The leftover straw is returned to the field like a natural mulch, while the clean kernels are collected into an onboard storage tank. Each modern harvester can collect over 90 tons of wheat per hour, an astonishing figure, equal to the labor of hundreds of workers operating non-stop, leaving behind the bulky, complicated machines of the past that once dominated the fields. These days, farmers no longer have to bend over with sickles to harvest each stalk by hand. But that doesn't mean they have it easy. The fields today are more expansive than ever, stretching endlessly to the horizon, so vast that even a bird in flight might never reach the end. To make it more challenging, harvesting can only happen in the early morning or late afternoon, when moisture levels are just right to avoid cracked or damaged grains. That's why lunch often means a cold meal eaten in a hurry under the shade of a harvester, chewing between rows, eyes still watching the field bathed in golden light. Out here, every minute counts, and true rest becomes a rare luxury during harvest season. Then it's right back to the harvest. Grain tank is full, the wheat is unloaded directly into large trucks driving alongside the field, or a specialized truck drives alongside the harvester, receiving a steady stream of wheat pouring from the unloading pipe, all happening seamlessly, without the machine stopping for even a second. This synchronized and precise process helps optimize time, maintain ideal freshness and dryness, and preserve the grain's quality, minimizing post-harvest losses to the greatest extent. After being harvested from vast wheat fields, the grain is transported to a grain storage facility. Here, the wheat is unloaded into underground receiving pits. These are steel-reinforced pits, built directly beneath the receiving area of the facility. From these pits, the wheat is moved by conveyor belts or bucket elevators into large silos, towering cylindrical storage tanks made of steel or concrete. Inside the silos, the wheat is stored under strictly controlled conditions for humidity, temperature, and ventilation. Inside these seemingly empty metal ducts, tons of wheat grains are silently moving, weaving through every bend and corner, making their way to specific areas such as cleaning machines and moisture conditioning units within the factory. After being thoroughly cleaned and resting inside massive silos, wheat begins its next journey, heading to the flour mill. But instead of walking or hopping on a train, the wheat slides through enclosed pipes and industrial chutes. At the end of the slide, tons of golden wheat grains come rushing down into enormous trucks, each capable of carrying 25 to 30 tons, roughly the weight of 5 full-grown elephants. But don't think they can just hit the road right away. Before leaving the site, each truck must pass through an electronic weigh station, ensuring the load is within legal limits and recording the exact weight down to the last kilogram. This strict monitoring isn't just about avoiding overloaded trucks. It's also essential for inventory management and traceability. In the food processing industry, every grain of wheat must have its own identity papers. Inside the flour mill, after undergoing initial cleaning, the wheat grains are passed through an additional round of screening, this time much more meticulous. From the screening section, the grains are sent to a central distribution hopper system, where automated valves precisely control the flow of wheat into the next stages of processing. However, before they can be milled, the grains must go through large tempering tanks. The wheat is lightly moistened and left to rest for 12 to 24 hours. This softens the outer bran layer, making it easier to separate during milling. Next comes what's often referred to as the heart of the factory, a long line of modern roller mills. In modern factories, a single production line can include 20 to 40 machines like this, each responsible for a different stage of grinding, from coarse to intermediate to fine milling. This setup maximizes both efficiency and flour quality, especially for specialty flours like pizza flour. Each pair of steel rollers spins steadily, crushing the wheat kernels and gently separating the bran, the germ, and the bright white endosperm inside. It's this endosperm, rich in starch and protein, that becomes the smooth white flour, the very foundation of a perfect pizza crust. After milling, the flour isn't ready for packaging just yet. You think those machines bouncing up and down like they've had one too many espressos? They're not dancing for fun. They're plan sifters, the unsung heroes making sure your pizza flour is smoother than your best pickup line. A large rectangular machine suspended by flexible rods, containing multiple layers of fine mesh screens. The machine gently vibrates, allowing the flour to be sorted by size with micron-level precision. Flour that meets the standard moves forward, while coarser particles are sent back for regrinding. This is the final and most critical sifting stage, ensuring pizza flour comes out consistently fine and high quality. Because with pizza, even the tiniest inconsistency can throw off the perfect crust. Next, the fine flour is transported through a high-pressure pneumatic system. Think of it as a high-speed expressway just for flour. It's carried to a cyclone separator, where centrifugal force separates the flour from the airstream, allowing for clean, dust-free, and lossless recovery. And those tangled stainless steel pipes that look like a maze? They're part of the system that delivers flour to the blending station. Here, the fine flour is given its final adjustments. Depending on the end product, enzymes, malt flour, or B vitamins may be added. Finally, after passing the last quality check for fineness and fluffiness, the flour is sent to the automated packing area. Here, every stream of fine flour is precisely weighed, filled into pre-labeled bags, and tightly sealed to preserve its freshness. Each bag typically weighs around 25 kilograms, just the right size for bakeries and food factories. Robotic arms carefully lift each bag of flour one by one, smoothly rotating and placing them neatly onto waiting pallets. The finished flour bags are then neatly stacked in climate-controlled storage, where both temperature and humidity are carefully monitored. And just like that, every pizza crust begins with a journey this meticulous. Now comes the moment we've all been waiting for. Don't forget, we're still on a journey to create the perfect pizza. It all begins with the crispy, chewy crust, the foundation that can make or break a great pizza. Once the dough has rested long enough, it's divided into long strips and passed through rollers. Next, the dough enters the shaping and cutting stage, where circular, square, or oval cutters form each base precisely. Have you ever noticed those tiny little holes on a pizza crust? They look like someone gently poked the dough with a fork. Those holes actually help steam escape during baking, preventing the crust from puffing up or cracking. And this is where the real differences begin to show. If the croissant is a symphony of butter and layers, Pizza is a playground of tomato sauce, cheese, and whatever flavors your heart desires. At this stage, the pizza crust is partially baked to set its structure. Lightly dry the surface and prevent the tomato sauce from soaking into the dough later on. Next, the tomato sauce is gently spread across the crust. This special sauce is made from ripe, juicy tomatoes blended with garlic, oregano, basil, and a touch of olive oil, creating a rich, slightly sweet and aromatic flavor that defines a classic pizza. The automatic cheese applicator operates with absolute precision. It uses fresh mozzarella, a cheese famous for its smooth melt, glossy finish, and rich texture that stays soft without releasing excess moisture. This is the secret weapon behind the irresistible appeal of every pizza. The amount of cheese is pre-measured according to specific recipes, depending on the pizza type, from classic to premium, to ensure the perfect stretch and deliciously melty richness when baked. Next, toppings like pepperoni, sausage, or bacon are automatically distributed over the freshly layered cheese. Slices of bright red pepperoni are neatly arranged, creating a visually appealing pattern and ensuring every bite is packed with rich, savory flavor. Before packaging, each pizza takes a quick trip through a gentle heating tunnel, like a mini spa session where the cheese melts just enough to hug the toppings tightly. This helps lock everything in place so nothing slides around during transport. Even better, the heat gives the surface a light sterilization, keeping the pizza fresh and safe for longer. After exiting the heating tunnel, the pizzas are moved to the packaging area. First, each pizza is tightly wrapped in plastic film to preserve freshness and maintain its shape during transport. Then, it's placed into a tray or box, labeled with product information and expiry date, and sent to cold storage for preservation before distribution. After that, the pizzas are transported to supermarkets, convenience stores, and distribution centers across the country. They are kept in consistently cold conditions throughout the journey to preserve their quality. And just like that, each fresh and delicious pizza is ready to become part of the daily meals of millions of families. If you enjoyed this video, don't forget to like, share, and leave a comment. More than 5 million tons of cocoa sustain the billion-dollar chocolate industry, mostly from West Africa, especially Côte d'Ivoire and Ghana. Yet almost all of it is still harvested by hand, because with rugged terrain, fragmented smallholder farms, and the delicate structure of cocoa trees, whose pods grow tightly against the trunk, mechanization remains limited. By September each year, cocoa plantations enter peak harvest season. Ripe pods are usually yellow, orange, or red, but green ones can still be cut because each variety ripens in a different color. To harvest, farmers use long, curved machetes, traditional tools that have existed for hundreds of years, and with a single precise cut, they can remove the pod without damaging the tree. In addition, specialized pruning shears are also used to handle pods that are lower and easier to reach. Meanwhile, for pods high above or hidden deep in the canopy, long poles fitted with curved blades at the tip are the perfect choice for cutting without climbing the tree. Freshly cut pods are gathered for the legendary step, bean extraction. Splitting a cocoa pod requires a sharp knife and just enough force to avoid crushing the beans. Inside, the seeds wrapped in tangy white pulp are scooped out by hand. A skilled worker can handle 150 to 200 pods per hour. That may sound low, but beginners often achieve only half of that, meaning an income of about $1 per day can be further split apart simply due to slower hands. The beans are then transported to processing sites. In some regions with muddy terrain and poor roads, donkeys are still used today as reliable means of transport. Crude and slow as it is, this land of scarce resources but abundant low-cost labor remains the backbone that supplies up to 70% of the cocoa for the global chocolate industry. And clearly, the journey of the calloused hands that sweeten the world is nowhere near as sweet as the final product they create. Cocoa beans, once they leave the plantation, cannot be used immediately and must undergo a fermentation process lasting 5 to 7 days, a step that determines 60 to 80% of the final chocolate flavor. Traditionally, the beans are fermented in layers of banana leaves, where heat and natural microorganisms trigger the breakdown of the mucilage, kill the embryo, and develop precursor aromas. Today, most cocoa is fermented in multi-tier wooden boxes that allow even turning and better temperature control. The ideal temperature throughout fermentation must stay between 40 to 50 degrees Celsius, with the bean mass kept aerated and not overly moist to avoid anaerobic fermentation. Crucially, the beans are turned once a day from the second or third day onward, a vital step to distribute heat and oxygen. Just one mistake, such as delayed turning or excess water, can leave an entire batch overly acidic, off-flavored, and severely downgraded. This is an irreplaceable link in the journey that transforms raw, sharp-tasting, fruit-scented cacao into premium chocolate. After 5 to 7 days of fermentation, when the beans have turned dark brown and release a characteristic cocoa aroma, the wet beans are brought out to dry under the sun for up to 7 days. This is a crucial step that reduces moisture from over 60% to around 7%, meeting storage and export standards. Farmers usually dry the beans directly on concrete yards or bamboo mats. In some areas, raised drying racks with roofs are used to avoid sudden rain. This stage also demands precision. The beans must receive enough sunlight each day, be stirred constantly to dry evenly, and kept free from moisture or mold. Just one damp spot can ruin an entire batch of cocoa. Once the cocoa beans reach the proper dryness level, they are sorted to remove impurities, flat beans, and low-quality fragments before being bagged and stored. After receiving confirmation from buyers or collectors, the entire batch is transported to the export port, ready to set off abroad, heading toward a dazzling world of precision machinery and polished production lines, the chocolate factory. Now, let's step into the most anticipated part, the chocolate production paradise of the world's most developed countries, where modern production lines dominate this billion-dollar industry. At the factory, cocoa beans, once received, must undergo a quality inspection before officially entering the chocolate-making process. A step that seems simple, yet is absolutely non-negotiable. After passing inspection, the qualified batches are sent straight to the cleaning area. Workers slice open the bags, pour the beans into the feeding hopper, and send each cocoa bean one step closer to its mission of becoming chocolate. And when everything is finally in place, the most crucial step to unlock the cocoa's true flavor begins: roasting. At bean-to-bar facilities or small-scale workshops, the most common choice is paddle-style roasters. Inside is a semi-closed roasting chamber where rotating paddles constantly toss the beans to ensure even heat exposure. This type of machine allows direct observation of the bean's color, aroma, and sound throughout the roast, while offering flexible temperature control from 100 to 140 degrees Celsius, adjusted in small increments with just a few buttons. The paddle speed can also be fine-tuned to suit different roasting styles, a major advantage for small batches requiring precise manual adjustments. In industrial factories, drum roasters with capacities of hundreds of kilos per batch are the optimal choice. After the beans are roasted, they move on to the next step, separating the shells to obtain the cocoa nibs. Large-capacity winnowing machines can process hundreds of kilos of beans per hour, operating on the principle of cracking the beans and then using strong air currents to blow away the lighter shells while retaining the heavier nibs. A multi-stage sieving system further sorts the nibs by size, ensuring that only those meeting the required standards move on to the next stage. The next step takes the freshly separated nibs into the grinding system to create cacao mass, the foundation of the entire chocolate industry. First, the nibs are coarse ground using roller crushers to break down their structure and release the natural cocoa butter, gradually turning the mixture from solid particles into a thick paste. The mixture then moves into ball mills or granite stone grinders for deeper refinement, reducing particle size to just 15 to 30 microns. Heat generated from friction melts the cocoa butter, transforming the mass into a smooth, homogeneous cocoa liquor, the core ingredient that determines the silkiness, richness, and flavor profile of the final chocolate. A portion of the cacao mass is fed into a massive hydraulic press to separate the cocoa butter. Under tons of pressure, the melted cocoa butter flows out in a steady stream, while the dry cocoa cake is pushed aside to be ground into powder. A fun fact: chocolate melts in your mouth, but not in your hand, and cocoa butter is the secret behind that. The dry cocoa cake is then fed into a specialized grinding system to produce cocoa powder. High-speed grinders break the solid cake into fine particles, resulting in a light, fluffy cocoa powder with a rich aroma, an essential ingredient in confectionery, beverages, and chocolate production. And once all the core ingredients, cocoa mass, sugar, and cocoa butter, are ready, they are poured into an industrial mixer for blending, the opening step that defines the structure and flavor of the chocolate. First, the cocoa mass is stirred and warmed. Then, sugar and cocoa butter are added in sequence, transforming the mixture from loose, dry particles into a thick, cohesive crumb. The mixer continues to knead and compress the blend so that sugar particles become evenly coated with fat, forming a uniform pre-chocolate base. Once it reaches the proper consistency, the mixture moves directly into the conching stage, where chocolate is refined, aerated, and polished to perfection. Conching, the most critical refinement step in chocolate making. In this stage, the chocolate mixture is continuously agitated, ground, and aerated in conch machines for anywhere from a few hours to over 72 hours, depending on the desired quality. Heat and friction drive off acidic notes, smooth out harsh flavors, and allow cocoa butter to fully coat every solid particle, creating a silky texture. The process also deepens aroma development through oxidation and the release of complex flavor compounds. The result: chocolate with its signature smoothness, shine, and refined, well-rounded flavor. When the conching process is complete, the liquid chocolate is kept warm in controlled holding tanks to maintain a stable viscosity before moving into the molding stage, the final shaping step that determines the product's appearance. In modern factories, the molding process is almost fully automated. A conveyor system carries clean polycarbonate molds through a vibrating unit, after which liquid chocolate is precisely deposited into each cavity by dosing nozzles. Immediately after filling, the molds pass through a high-frequency vibrating table to remove air bubbles and ensure the chocolate spreads evenly, preventing surface holes or cracks in the finished product. Next, the molds enter a cooling tunnel set to a precise temperature range, allowing the chocolate to solidify and contract slightly for easy demolding. Once properly cooled, the molds are inverted and gently tapped by a mechanical system so the bars or pieces of chocolate fall onto the conveyor. From here, robotic arms or automated belts transfer the pieces through inspection, wrapping, packaging, and boxing. Every step runs seamlessly, cleanly, and accurately, completing the long journey from raw cacao to glossy, finished chocolate ready for the shelf. Meanwhile, trucks loaded with freshly harvested wheat take a different route, heading straight to the donut factory, where magic happens and a bit of culinary wizardry transforms nature's golden grains into sweet, enchanting rings of delight. Once delivered to the factory, the wheat goes through a thorough cleaning process using advanced machinery. This step removes impurities, such as straw, soil, stones, and husks, ensuring that only high-quality wheat kernels are retained for donut production. After cleaning, the wheat is fed into roller mills, where the kernels are gradually crushed and ground through multiple stages. The final result is a fine white endosperm, the purest part of the grain, which becomes the key ingredient in creating those golden, delicious donuts. The flour obtained after the milling process enters the first stage of donut production, ingredient mixing. At this point, the flour is combined with eggs, sugar, baking powder, and water, forming the perfect base mixture that gives each donut its signature flavor. All ingredients are precisely measured and fed into a specialized industrial mixer featuring a spiral design. The spiral mixing blades are engineered to mimic hand-kneading movements, ensuring the dough is both evenly mixed and properly stretched. Some machines are also equipped with heat sensors to monitor the temperature during mixing, as excessive heat can kill the yeast or compromise the quality of the ingredients. Modern industrial mixers can handle up to 200 kilograms of dough per batch, enough to produce over 4,000 donuts in under 10 minutes. After being mixed to the ideal smooth and elastic consistency, the massive dough is released from the mixer by an automated lifting system, allowing the soft, pliable mass to flow evenly into the feed chute below. This process not only ensures hygiene, but also keeps the production running smoothly, perfectly setting the stage for the sheeting process, a crucial step that determines the shape and rise of each donut once fried. Here, the dough blocks are first neatly trimmed to remove any excess, then rolled out evenly by machines into thin, flat sheets as smooth as paper. The rolling process ensures the dough spreads uniformly, creating a perfect foundation for the next stages of processing. Advanced machinery guarantees each step is precise, consistent, and minimizes material waste, maintaining stable quality from start to finish. To prevent the dough sheets from sticking together during the rolling process, a fine layer of dry flour is automatically dusted onto the back of each sheet. This task is carried out by a specialized rotary brush system, typically made from food-grade synthetic materials like polypropylene or nylon. These brushes are usually blue to ensure easy visibility and strict hygiene control. After the dough has been rolled to the precise thickness, it moves on to the cutting station, where sharp cutters rhythmically press down, stamping perfect circles onto the surface. The result is a series of evenly spaced dough rings, each with a hollow center, appearing as if printed by a mold. Every donut is shaped with millimeter-level precision, ready for the golden, crispy frying journey ahead. The entire production line moves in perfect sync, like a finely tuned machine, transforming lifeless sheets of dough into beautiful, uniform donuts. To create the iconic holes, the signature feature of every donut, a specialized punching rod presses down precisely into the center of each dough piece, forming a perfectly round hole. The applied pressure is carefully calibrated to avoid tearing or deforming the dough. The entire process runs continuously, in sync with the automated production line. Right after the hole is punched out, the excess dough around the edges is gently collected by a vacuum-assisted system. This dough is then transferred to a specialized recycling unit, where it is carefully rolled and fed back into the dough mixer to be combined with fresh batches. Reusing this leftover dough not only prevents waste, but also gives new life to what might have been discarded, helping to create donuts that are consistently uniform and perfect, right down to the very last one. Freshly cut donuts are carefully transported to the proofing station via a conveyor system. The donut dough is then automatically placed into molds on trays with ventilation holes, allowing proper air circulation before they are submerged in the frying oil. The donut pieces glide smoothly along the conveyor belt, carefully guided toward the frying station. Each piece maintains its shape as it moves steadily through the automated system, ensuring they arrive perfectly positioned for the next crucial step, being gently lowered into the hot oil. This precise movement helps preserve the quality and consistency of every donut before frying. And then, the magical moment arrives. The automated conveyor system gently lowers the donuts into massive vats of hot oil, heated to between 170 and 190 degrees Celsius. The system meticulously fries and flips each donut to ensure both sides are evenly cooked within 45 to 90 seconds. On modern production lines, these conveyors act as skilled assistants, taking over the flipping process to help each donut achieve that perfect golden crispness. Inside the giant fryers, you'll witness an enchanting transformation. The small pieces of dough gradually puff up like fluffy pillows, thanks to the interaction between leavening agents and internal moisture, a spectacular rise into irresistible golden brown donuts. Properly fried donuts feature a distinctive white ring around the center. Not a flaw, but a hallmark of a well-cooked donut. This pale band indicates the part that didn't directly touch the oil during the expansion. If the entire donut turns uniformly golden, it may have been fried for too long or at too high a temperature. Hot oil is the key partner in giving donuts their golden crispness, but if not properly managed, it can become a flavor-ruining culprit, making the donuts greasy and stripping away their light, delicate texture. That's why removing excess oil is a crucial step in the process. Once perfectly fried, the delicious donuts are transferred to another conveyor belt that leads to a specially designed cooling system. This system, equipped with tiny perforations, helps control and remove any residual oil left in each donut. Once the donuts are perfectly fried and drained of excess oil, they continue their journey along the conveyor belt to the automated glazing chamber. Here, each donut passes through a sweet glaze curtain, a continuous, flowing cascade of warm glaze that gently coats the entire surface of each donut like a sugary waterfall. Thanks to the precise design and steady flow, the glaze is evenly distributed. Not too thick to make the donut overly sweet, and not too thin to lose that signature melt-in-your-mouth sensation. The glaze is typically made from a blend of sugar, water, vanilla, or condensed milk, and sometimes includes natural colors or flavors like chocolate, strawberry, or caramel, creating a variety of unique donut styles. Any excess glaze flows off the sides of the conveyor system and collects in a container below, where it is recirculated and used again for the next batch of donuts. In addition to the traditional sugar glaze, donuts can be finished with a wide variety of delicious coatings, with chocolate being one of the most popular choices. Chocolate-covered donuts offer a rich, indulgent flavor that captivates sweet lovers of all ages. As the conveyor moves, each donut passes through a thin layer of melted chocolate. The process is precisely designed to ensure an even, smooth coating. Machines either dip the bottom or apply the chocolate from below, allowing full coverage. As a result, the donuts are finished with a glossy chocolate layer that's as appealing in taste as it is in appearance. After the glaze is partially dried, the donuts move on to the colorful topping station, where the decoration magic begins. Here, the conveyor gently carries each donut through an automated topping system designed to add the finishing touch. Thousands of tiny, colorful sugar pieces, known as rainbow sprinkles, are evenly sprinkled from above or from both sides, sticking to the still slightly wet glaze. They create a festive, carnival coat that's light, crispy, sweet, and vibrant. The system can be easily adjusted to use shredded coconut, chocolate flakes, crushed nuts, or themed toppings. With this final step, each donut becomes a sweet little masterpiece that delights both the eyes and the taste buds. After the toppings are added, the sweet donuts move on to the inspection and packaging process. From start to finish, Machines handle almost the entire donut-making operation, but in this final stage, it's the human touch that puts the finishing mark on the journey. Skilled workers carefully inspect each donut before sending them to the automated packaging system. There, machines wrap each donut in colorful plastic bags and seal them to preserve their moisture and freshness. The packing process is fast, yet highly precise, ensuring that every donut is carefully sealed. These protective wrappers not only help maintain the donut's soft texture and delicious flavor, but also preserve their just-made freshness, ready to delight taste buds wherever they go. From humble flour to golden perfection, and now, dressed in vibrant packaging, each donut is not only perfectly preserved, but also ready to hit the shelves, awaiting the moment it delights the taste buds of millions.